demo how you can use GuardDuty, a managed security threat detection service from AWS, to detect the S3 bucket related attacks and also remediate the risks associated with it. If you haven't watched my first GuardDuty session, you can watch it in my channel, which is related to the EC2 threat detection and risk remediation. So now let's recap the demo environment. There are two EC2 instances acting as the attacker and the victim accordingly. The malicious host, which shows on the left, actually represent the attacker, which we pretend is running on the internet. The elastic IP on the malicious host is actually in the custom threat list in the GuardDuty. And the other instance, named the compromised instance, shown here, it's represent the web server that was lifted and shifted into AWS recently by your company. Although the company policy is that only key-based authentication should be enabled for SSH, at some point, the password authentication for SSH was enabled on the compromised instance. This misconfiguration was identified in the inspector scan that was triggered from the GuardDuty finding. The malicious host performed a brute force SSH password attack against the compromised instance. The brute force attack was designed to be successful. The SSH brute force attack was successful, and the attacker was able to log into the compromised instance. And then the compromised instance also has a cron job that continuously pings the malicious host to generate a GuardDuty finding based off the custom threat list. The malicious host then would use the credential to call the AWS API, such as S3 Service API, to make the S3 bucket become public, so to breach the data. So now we have a login to the demo environment. So from the GuardDuty service page, we can see multiple findings have been shown up here because we have been running this demo environment for a couple hours. And the thing I want to highlight are the top two findings. If we click into the first one, which is related to the S3 bucket, and we can see this finding was related to the server access logging disabled. And from the description, we can see this can lead to the lack of visibility into the actions taken on the affected S3 bucket and its object if an event occurs. So what that means is because the server access logging has been disabled, so even if any event occurred, there's no logging that's being captured for it, so it's quite dangerous. That's why even though this severity level low of the findings, we still need to look into that. And if we scroll down a bit in the overview section, we can see some of the related information, including the impacted account ID. Apparently, this is our account ID and the resource ID. And this actually is pointing to the S3 bucket. And you can see some of the time tag. The latest updated finding time was actually 15 minutes ago, so it's still quite current finding. If we scroll down a bit, you can see more information around the resource affected, and we can find the IAM user actually listed here, and this is the username. So what happened is because as we mentioned, the malicious user actually has conducted a brute force attack to breach the EC2 instance, retrieve the temporary credential, use that to breach the IAM user, and then in this case, it actually has retrieved the IAM users, IAM roles and information. That's why you can use it to call the AWS API to change the information. That's why the resource affected will also include the IAM user. If we keep scrolling down a bit, we can see more information about the impacted resource S3 bucket and also the owner tags. The thing I want to highlight is here in the action section. We can find this is an AWS API call, so we can see this is data plane action rather than the management plane actions. And if we scroll down a bit, another thing that we need to understand is this IP address for the actor. It was actually the IP address that's associated with one of the EC2 that we use to be the simulated attacker, which we will showcase shortly. And now if we copy the IP address of the actor and switch to the EC2 instance page, we do a search, then we can find this IP address was associated with an EC2 instance called this name, the GuardDuty IC instance. So what happened is, as we mentioned before, the attacker actually used the brute force attack to breach the EC2 instance as the victim. And then it got the EC2 instance credentials, the temporary credential, and then to try to use it to call the S3 bucket API to change the attribute of the S3 bucket. That's why GuardDuty will raise the findings. So now let's look at the second S3 related GuardDuty finding here. If we click into it, we can see this is S3 bucket block public access disabled related finding. So what that means is someone actually is trying to disable the public blocking functionality on this bucket. And even though this is a low severity, we still need to look into that, because if this has been gone through, and then someone actually from the external environment will be able to access our S3 bucket data, which can cause a data breach. So if we look into that, so this also gives us some of the similar information as we saw back in the first findings related to the impacted account IDs, resource ID. And if you can recall, this resource ID actually point to the S3 bucket that's been impacted. Resource impacted also, we can see the same IAM user has been impacted. If we keep scrolling down, more detailed information around the S3 bucket. And at the moment, it is still not public. And if we keep scrolling down, we can see this is also an AWS API call. And also, we notice the same IP address of the actor actually was existed here. So based on the two GuardDuty finding, now we need to take actions to manually remediate the risk. The first action would be, let's manually to enable the server access logs for the S3 bucket. Then we can copy this S3 bucket resource ID, or we just click in the link. Then we would find this S3 bucket here. We click into the bucket name, and then we go to the property tab. If we scroll down, and then we will find there's a section mentioning the server access logging. At the moment, the status is disabled. So we need to edit it. We need to enable the logging. And then now we need to specify target bucket. At the moment, we already have the bucket for here. So we select this bucket for the detective usage. We save the change. All right, so this shows the change has been gone through. And if we scroll down a bit, we can see now the status of the server access logging was enabled. So apart from enabling the server access logging, now let's enable the public blocking. So we need to go to the permission tab of the S3 bucket. And then we scroll down, we can see here the block all public access was set to be off. We need to edit it. Click here, we take the checkbox here, block all the public access, which was actually the default setting for the S3 bucket. Then we can save the change. We type in the confirm and click the button. Now the change has gone through, and if we scroll down a bit, we can see all the public access have been blocked. So now we have demo how can you use the GuardDuty to detect the S3 bucket related security attack and also take actions to remediate it. I hope you enjoyed this session, and if you find it helpful, please take a like for it, and also welcome to subscribe to my channel. Thank you. Bye for now.